In the procedure for the compression test, the most important part, once again, is check if you have the manual appropriated for that engine. And let me explain something about the procedure to do the compression test in a diesel engine. Verify if you have the appropriated tools, the appropriated specific tool in order to do the compression test for that specific engine. In order to do the compression test, we are going to remove the injector. Remember, the injector have normally in one side the input of the fuel and the return on top. The return on top of the injector. The return of the fuel, 80% of the fuel return on top into the fuel tank. The input is in the side of the injector, 20% of the fuel enter over there, and 80% of the fuel return on top into the fuel tank. Alright, you need disconnect carefully the input and the return using the appropriated wrench. And right now, you can remove the bolt. Normally, one bolt keep the injector against the block, against the head. Alright, right now, you need to verify if you have the tool appropriated to remove the injector. Because normally those injectors are completely seized, completely like welded with the head. Remove the injector is not easy. In general, you need to use appropriated tools recommended by the manufacturer to remove the injectors. Don't try to remove the injectors with hammer, with the vice grips. No, never try to apply the torch. Never try to apply heat on the injector because you destroy the O-rings. You destroy the internal elements on the injector. You damage the injectors. The injectors, if you use the torch, you destroy the injectors. All right? Never try to use the torch. Okay, you need to be 100% sure that you have the set with the tools, with the sockets appropriated to remove the injectors and replace the injector for the appropriated tool. You can replace the injector for the appropriated tool with the same external diameter in order to fill exactly the same hole that the injector occupied. You remove the injector and you introduce the tool in the same hole, and that tool, in one end of the tool, is connected with the pressure gauge. The pressure gauge is connected on the tool, and the tool should be attached to the head by bolt or by pressure. There are different type of tools. If you have that tool and you have the pressure gauge appropriated, you can do the test procedure. If not, never try to do the compression test if you don't have the tool appropriated to remove the injectors and the tool appropriated to replace the injector and connect the pressure gauge. Alright? This is the most important part, and this is the most difficult part. The most difficult part is remove the injectors and install the tool appropriated for that specific engine. If you have the set with the tools, you can replace the injector for one of those elements on the set and you can connect the pressure gauge. And right now we are going to follow this procedure. This is the procedure that we are going to follow cylinder by cylinder. Okay, when the tool is inserted into the hole where the injector was located before, we are going to fix that tool properly, and right now we are going to crank the engine 4 times, 5 times until the pressure reach the maximum pressure recommended for the manufacturer in the manual. Once again, if you don't have the manual, don't try to do that procedure. In the manual, the manufacturer recommends the pressure that you have on the screen right now. This is the pressure recommended for that specific injector. And right now we are going to crank the engine 1, 2, 3, 4, 5 times until the pressure reach the pressure recommended for the manufacturer. And we are going to create a table like this. We are going to do a table like this. Suppose that we are going to put a small example here, and we are going to verify. We are going to put here cylinder 1. We are going to put cylinder 2, cylinder 3, and cylinder 4. Suppose that the engine is 4 cylinders. It's exactly the same for 6 cylinders, 8 cylinders, 10 cylinders. It's exactly the same. And we are going to check. Suppose that the pressure recommended for the manufacturer should be around 600 psi. It's an example. And we are going to check. We are going to do 2 attempts. This is the attempt number 1, and this is the second one. Okay, in the first one, in the cylinder number 1, I have 550, and in the second attempt, 560. Alright. Cylinder number 2. Cylinder number 2 is 400 and 380 psi. Cylinder number 3 is 400 and 350. And cylinder number 4, 600 and 620. This is an example. This is a typical example. Okay. What happened in that particular engine? What happened in cylinder number 2 and cylinder number 3? In cylinder number 2 and cylinder number 3 are below the pressure recommended for the manufacturer. The compression in those 2 cylinders is lower than the pressure recommended for the manufacturer. Now we need identify if the problem in those cylinders is because the rings are broken or wear, or because the valves don't close properly, or because the head gasket is damaged and you have a leak. In other words, we are going to verify if the leak is through the piston rings, or if the leak is through the valves, when the valves don't close properly, or if the leak is through the gasket in between the block and the head. We have 3 possibilities: rings, or valves, or head gasket. How can we identify where is the problem? It's simple. In this particular example, we have 2 cylinders with problems, and we need to identify if the problem is on the rings, on the valves, or on the gasket. Let me explain something. Suppose that, like this, I have 1 cylinder with low compression. Okay, I am going to remove the compression test element, and we are going to add a little amount of engine oil, motor oil, the same oil that you use regularly in that engine. And we are going to introduce a little 0.5 ounce of oil. What is the function of the oil? The oil goes into the head of the piston and seal around in between the cylinder and the piston head. And now we are going to install again my compression tester, and now we are going to crank the engine again, and we are going to verify, oh, the compression right now is 650. The compression increased. Alright, where is located the problem in that cylinder? On the piston rings. Yeah, because the oil sealed the gap in between the cylinder and the piston head with oil, and right now the compression increased. I am 100% sure that that cylinder have a problem with the piston rings. Yeah, we need to replace piston rings, or we need to hunt the cylinder. This is the next project, and we are going to replace the piston rings. Okay, what happened if I added the oil on the hole and I connect my compression tester again, I crank the engine 5 times and the compression continue low, 350, 380. The problem is on the valves. One valve stay open, or one valve is cracked, or one valve was melted, or one valve stay open all the time because the spring is broken. The problem is on the head. Or what happened in this particular example? I have 2 consecutive cylinders with low compression. I have 2 consecutive cylinders with low compression. This is a perfect indication that the problem is on the head gasket. When you have 2 consecutive or 3 consecutive cylinders with low compressions, it's because the head gasket is blown, because the engine was overheating, the head was bended, and the head gasket was flooding, and the oil passed into the coolant. 100% sure that in this particular engine with 2 or 3 cylinders adjacent with low compression, if I check the oil, probably the oil is a milky oil. The oil is emulsified with coolant, and the color is the color that you have on the screen right now. This is an indication that the head gasket was blown because overheating for some reasons, other mechanical reasons that we need to identify. And right now the compression is low in those 2 adjacent cylinders or 3 adjacent cylinders. Okay, we are going to summary the information. In order to do the compression test, we need, first step is keep the manual appropriated according with the serial number and the model of the engine. The second one is be 100% sure that you have the tools appropriated to remove injectors and install the new tools over there, and verify that the tools are appropriated according with the diameter of the hole on the head. Now install the tools appropriated, install the pressure gauge appropriated, crank the engine 4 times, 5 times, and verify the maximum pressure on the gauge of the pressure gauge. Alright? And copy that number in the table and repeat the procedure 1 more time per each cylinder. In other words, it's 2 times per cylinder. Copy all the information in the table and after that analyze the situation. I have only low compression in 1 cylinder. Okay, let me check if the problem is on the valves or on the rings or on the head gasket. Alright, let me add a little amount of motor oil. And now I install again the compression tester. And now I crank the engine again. Oh, the compression increased dramatically. Alright, the problem is on the rings. Oh, I added the oil and I crank again and the compression stay low, low, low. The problem is on the valves. Oh, I have low compression in 2 or 3 adjacent cylinders. This is a typical problem of the head gasket. The head gasket is blown for some reasons. We need to remove the head, send the head to the machine shop in order to cut the head and replace the head gasket and try to start the engine again and verify if the problem was solved.